This is a very simple question regarding the conductometric titration. You are asked to determine the conductometric titration of HCl against ammonium hydroxide, hydrochloric acid against ammonium hydroxide. So let us see. I'll be giving some tricks not only to solve this one but to solve all the acid-base titrations. So let us see how to solve it. So if you see a question like this, first you have to see which one you are taking in the beaker. So it is asked as titration of hydrochloric acid against ammonium hydroxide, meaning to say you are titrating hydrochloric acid in the beaker and ammonium hydroxide from the burette. So for this titration, I'll be taking HCl here and NH4OH here. So now your titration is like this. So first you have to draw a schematic graph, and of course since HCl you have taken here you will be titrating with ammonium hydroxide. So here it will be volume of ammonium hydroxide, and here you will be starting with the conductance. Since you have taken HCl in the beaker, the conductivity meter will be giving the readings of HCl. HCl, as you know, is a very strong electrolyte. HCl dissociates as H plus plus Cl minus. It is a complete dissociation. And since the one of the product is H plus, which is a very fast moving ion by H plus ion by the Groth's mechanism, you can start the graph from the very high value if it is a strong electrolyte from here. Now, in the reaction, HCl is reacting with NH4OH, giving you NH4Cl. It is not a dissociating salt, plus H2O. So meaning to say your products are not giving any conductance. And also whenever you are adding ammonium hydroxide against HCl, the H plus ion is getting titrated, meaning to say it is getting diminished. So in the initial stages you will be having in the next, after the next addition of NH4OH, the conductance will be decreasing. So at the end point what will be happening, all the HCl has been consumed, no more HCl at the end point. Now what is incoming is ammonium hydroxide. Up to that time all the ammonium hydroxide has been consumed. Now the excess of ammonium hydroxide will be there, but ammonium hydroxide, as you know, it is a very weak base, so it will be dissociating as NH4 plus plus OH minus, but this equilibrium is far more higher, meaning to say it will be existing as ammonium hydroxide itself. There will not be any change in the conductance. There may be a change, but it will be very less. So if you join these two curves like this, and this will be your endpoint. So this is the correct explanation for this one. And so this is a strong acid versus weak base titration. Now you check the options. So which are the options? Conductance increases till the end point. No, that is not the correct one. It is actually decreasing. Conductance remains more or less constant till the end point. No, the conductance is decreasing, so that is not the correct one. Now you see the third one, conductance remains more or less constant after the end point. So that is a correct answer. It will be remain more or less constant after the end point. You check, we will check the fourth option, increases after the end point. No, conductance will never increase, will have a sharp increase, because ammonium hydroxide is a weak base. So this also is a wrong answer. The right option is option 3. So always in this type of conductometric titration, remember which one you are taking in the beaker and which is in your burette. In the beaker, you check whether it is a strong electrolyte or a weak electrolyte, start the graph accordingly, and you check with the equation which all the ions are getting consumed in the reaction, and after the end point which type of electrolyte is going to be more, whether it is a strong or weak. With this information you can answer all type of these questions. If you have any doubts, please ask in the comments.